Hey everyone, and welcome. So, have you ever looked at a massive application and just wondered, how on earth do they handle all that data without completely falling over? Well, you're in exactly the right place. Today, we're going to pull back the curtain on MongoDB's really clever solution for this problem. It's called sharding. Let's jump in and see how it all works. Here's what we've got on tab. We're going to start with the why, the big problem that every growing app eventually runs into. Then, we'll look at the two main ways to solve it, and that'll lead us right into the anatomy of a MongoDB sharded cluster. After that, we'll see how you get one up and running, how the data magically finds its home, and we'll wrap it all up with the real power you get from sharding. All right, first things first, let's talk about the scaling problem. This is a challenge that really is a good problem to have, but it's one that every single successful app will face. Okay, so just picture this for a second. Your app is a huge hit. It's got users signing up like crazy, data is just pouring in, and that one trusty server you started with, it is now groaning under the pressure. It's running out of memory, the CPU's maxed out, and you're about to run out of disk space. So what do you do now? Well, this brings us to a really fundamental fork in the road when it comes to system design. You basically have two choices for how to handle this kind of growth. You can either scale up or you can scale out. Let's check out the difference. So vertical scaling, or scaling up, is kind of like trading in your car for a giant monster truck. You just get one much bigger, much more powerful server. More RAM, faster CPU, the whole deal. It works for a while, but it gets incredibly expensive, and eventually you're going to hit a wall. Horizontal scaling, or scaling out, is a totally different game. Instead of one massive server, you just add more regular-sized servers to a fleet and spread the work across all of them. And this right here is what sharding is all about. Sharding is simply MongoDB's name for horizontal scaling. It's the whole process of taking a massive dataset, breaking it into smaller chunks, and spreading those chunks across a bunch of different machines. This is what lets your database grow practically forever. You just keep adding more machines to the group. So what does one of these sharded clusters actually look like under the hood? It's not just a random pile of servers. It's made up of three key components that all have to work together perfectly. Let's break them down. First, you've got the shards. These are the real workhorses of the cluster. A shard is just a server that holds a piece of your total data. So if you have 4 shards, each one holds about a quarter of your data. But here's the really smart part for making sure your data is safe. Each shard should actually be a replica set, not just a single server. That means your data gets copied automatically, so if one machine goes down, no big deal, you haven't lost a thing. Next up is this thing called mongos. This is probably the most clever part, because it's what your application actually talks to. Think of it like a traffic cop. Your app doesn't need to know about all the different shards, it just sends a request to mongos. This traffic cop then looks at the request and says, you need data that lives over on shard 3, and it sends the request to the right place. It makes the whole cluster look like one single giant database to your app. And finally, you have the config servers. Now, if Mongos is the traffic cop, the config servers are its map, or its GPS, maybe. They store all the metadata about the cluster. They know exactly which chunk of data lives on which shard. This is the single source of truth for the whole system. Without this map, our traffic cop would have no idea where to send anything. Okay, so we know all the pieces of the puzzle now, but how do you actually put it all together and bring a sharded cluster to life? Let's do a quick flyby of the steps. It's a pretty logical process, really. You start by building the foundation. You get your shard servers up and running, and like we said, you should run them as replica sets for safety. Then you deploy the config servers. That's the brain of the operation. Once you have a place for your data and a brain to manage it, you can start up the Mongos traffic cops. And the last step is to connect to a Mongos and tell it, okay, use these shards and start sharding this specific database. It's a step-by-step assembly line. So the cluster's up and running. Great. But how does MongoDB actually decide which shard gets which piece of data? This is where a little thing called a shard key becomes absolutely critical. I mean, this is the million-dollar question, right? You've got, say, 10 shards. When a new user signs up, which of those 10 servers does their data go to? And later, when you need to find that user, how does Mongos know where to look without searching everywhere? It all comes down to how you set up your collection to be sharded. The answer is in a command that looks just like this. See, when you tell MongoDB you want to shard a collection, in this case our user's collection, you have to pick a shard key. That's a field in your documents that MongoDB will use to make its decision. Here, we're picking the ID field. And that little keyword, hashed, that's the real secret sauce. It tells MongoDB not to use the ID's value, but to run it through a hashing function first. This basically scrambles it, ensuring that all your new data gets spread out perfectly and evenly across all your shards. No single shard gets overloaded. Okay, so let's pull back and wrap this up by looking at the huge advantages you get with a sharded architecture. This is really the so what of it all. Why this is such a game changer for big applications. So what's the payoff for all this? Well, you get an actual answer to that impossible scaling problem. Instead of being stuck with one server's limits, you get practically infinite horizontal scale. If you need more capacity, you just add another machine. Simple. You also get a distributed workload. Since all the requests are spread out, no single machine gets bogged down, which means faster performance for your users. And because you built your shards as replica sets, you get high availability baked right in. The system is literally designed to handle failure. It's the full package: growth, speed, and reliability. And that's our whirlwind tour of MongoDB sharding. If this breakdown was helpful for you, do me a favor and hit that like button and subscribe for more explainers on cool tech topics. I'll just leave you with this final thought. As our apps get bigger and data just keeps exploding, the question really isn't if you'll need to scale, but how you're going to do it. Sharding is a proven way to get there. So take a look at your own systems. Is your architecture ready for what's next? Thanks for watching.